So we're trying to graph y equals 3 cotangent 1/2 x. Okay. If you multiply a function by 3, then it makes the function climb at a faster and faster rate, or in this case, it also makes it fall at a faster and faster rate. So it's like it's making the blue line be more constricted. It's like you're having two walls that are crunching in on it to make it climb at a faster rate. And the 1/2 x, the 1/2 is actually going to elongate it down here at the bottom. But probably the best way to check this out is to go to desmos.com/calculator. And here's regular cotangent x. And we can see what happens if we put a coefficient. If we multiply by 3, multiply by 4, multiply by 100, makes it almost a vertical line. Right? So multiplying by 3 makes it climb at a faster and faster rate. But when you divide by 2 or when you divide by 3, it's widening out that curve, how far apart it goes. Right? So like the period of our trig functions, the first one we studied was sine. Sine had a period of 2 pi when you didn't have any number here. But when you put in 1/2 in front of the x, then that changes your period because you need to divide 2 pi by 1/2. Except with tangent and cotangent, the base period isn't 2 pi, it's pi. Okay, so the period of tangent is pi. So the period of cotangent is going to be pi, but it needs to be divided by b, the absolute value of b. Okay, and so b is just that, the 1/2 that we're dealing with, the divide by 2. Okay, so this is our b. If you're dividing by 2, that's the same thing as multiplying by 1/2, right? So b is 1/2, and so that means instead of repeating itself every pi units like it does right now, if b is just 1, then every time we go 1 pi unit on the x-axis, it starts repeating itself, right? Here's x equals pi, and then the function goes back to the top again, goes all the way down. And then here's 2 pi. At 2 pi, it starts back at the top and then goes down. But since our b is 1/2, this thing is going to repeat itself. We gotta have 1/2 in the denominator, right? Because you're dividing by b. In other words, the period is now 2 pi. So every time you go 2 pi units, it should be repeating itself. Okay, so that's a lot of information. Let's put it all together when we try to graph this using Newton's software. So we need to find a particular value for this blue dot here. Okay, in order to make that happen. See, that doesn't move, it only moves vertically. Okay, so we should set the period first. Just like we said with that graph, it's pi divided by b. So pi divided by 1/2 is 2 pi. So it should repeat itself every 2 pi units. And then at pi over 2, we're supposed to say what the y coordinate is. So you can get that by plugging in pi over 2 in here for x. If you do that, pi over 2 times 1/2 gives you pi over 4. And cotangent pi over 4, we can find out what that is by drawing the angle pi over 4. That's a 45-degree angle, right? So that means the sides are square root of 2 over 2 and square root of 2 over 2 in the unit circle because the hypotenuse is 1. So it's one of those special triangles where we got square root of 2 over 2 and square root of 2 over 2. And cotangent would be the adjacent to the reference angle. This is the reference angle. So the adjacent to the reference angle divided by the opposite of the reference angle. So cotangent pi over 4 is just going to give us 1. So back in our graph, this is 1. It's being multiplied by 3. So this is where our dot should go.